Hey guys, my name is Gabriel Quest. I'm in group 2 and today I'm going to be explaining to you guys problems 2 and 12. Alright, so number 2 says that the electric potential in the region is constant. The electric field must be zero in that region. So the formula for electric potential is dV over dL or dr or dx, whatever that it may be. And ever since the electric potential is constant, meaning there's no rate of change, it means that it has to be zero because there's no rate of change. So that means that the answer is true instead of false, which I chose. It's true because constant means no rate of change. All right. Number 12. Number 12 says a non-conducting sphere contains positive charge distributed uniformly throughout its volume. Which statements about the potential due to a sphere are true? All potentials are measured relatively to infinity. There may be one more correct answer. So, knowing what we know, non-conducting sphere, the electric potential is it's inversely proportional to r squared. So, the potential at the surface higher than the potential at the center? False. The farther you get from the center, the less electric potential there is because it's a decreasing graph. Potential at the sphere is 0. It's impossible because it's decreasing, so I can't start at 0. The potential at the center of the sphere is the same as the potential at the surface. Like I said, not possible because it's a decreasing function, so meaning the potential at the center and the sphere are the same. Even immediately after some infinitely small measurement after the center, it's already smaller. Potential at the center is the same as potential infinity? Absolutely not, because the closer you get to infinity, the closer it gets to 0, the closer it gets to being nothing. Leaving the only answer, the potential is the highest at the center of the sphere because that's just true, that's fact. All right, thank you very much for listening. Have a great day.